And let me share the screen. Like this. Okay. So welcome to this technical talk of CTSoc. Thanks for joining. Good morning, good afternoon, and good night. This is the 17th webinar of this series, and let me introduce myself. I'm Fabrizio Lamberti. I'm the Vice President of Technical Activities of IEEE Consumer Technology Society. And the technical talks are an initiative of the technical activities areas that I'm coordinating. The technical activities areas includes the Future Directions Committee and the technical committees. It is a new area that has been created at the end of 2020, and within the technical activities, like in other societies of IEEE, we do have the technical committees. There are currently 15 technical committees which are covering broadly the various areas of interest and the broad field of interest of consumer technologies and consumer technology society. Today, we do have two technical committees represented through their speakers. So the QCT, Quantum in Consumer Technology, which is the youngest technical committees, and the Human-Machine Interactions and Human Experience TC. But as you can see, the committees spread a broad number of subjects. Each of these committees has its own chair, co-chair, and secretary. The technical committees are governed by the technical committees board, which is chaired by myself. The vice chair is Dixon Lean. And then here you have the main roles of Consumer Technology Society, which are represented in the TC board. So the president, Fabrice Labeau, the VP conferences, Fawzi Beman, the VP publication, Norbert Erengsar, and the VP industry and standard activities, Michael Condry. Plus, we have the chairs, vice chairs, and secretary of all the 15 technical committees, so you recognize some of their names in this list. This is for the term 2025 and 2026. Each technical committee has its own website. So its mission, has its officers, has its goal, has its own list of members, and you can go through this page and see many of you are members of the technical committees, but of course, if you are not a member yet, you might decide to join. And in any case, I encourage you to invite other people who are not yet member of the technical committees to join. Please note that you don't need to be a member of IEEE or IEEE CTSoc to be a member of the technical committees. And being a member of the technical committees means becoming a member of a community which currently has 1,500 members representing the various areas, and new members are joining periodically. We are advertising this possibility in a number of ways. And as I said, the technical committees are the backbone of the new backbone of the society of IEEE Consumer Technology Society, because they are supposed to support the conferences, publications, standard education and history, so all the areas of the society. And they are aimed to identify new... identify new areas of interest and also engage its members in all these areas. So just to make an example, there's a page on the main website of Consumer Technology Society that is listing the various opportunities that have been offered or are offered to our technical committees members, like the participation into the technical positions of conferences, of journals, workshops, participation in joint initiative with other societies like the digital reality, the digital privacy, with other societies like signal processing, like the audio engineering society, the creation of working groups, distinguished lecturers, these technical talks, funded projects, participation into standard activities and stuff like that. So you can go to this page. I'm listing here just a few opportunities that are currently offered regarding, for instance, our conferences. So you can help our conferences in many ways, like submitting, serving, organizing special sessions and stuff like that. These are conferences with open call for papers or open calls of some kind. And there are also new conferences that are being organized, like this is a 2026 conference on intelligent reality, which is organized by CTSoc and other six societies. There is at least another opportunity currently offered, which is serving as associate editor in one of the publications sponsored by Consumer Technology Society, the Consumer Electronic Magazine and Transactions on Consumer Electronics. There is a call for associate editors that have been circulated that will close on November 30. So if you are a member of the technical committees, and especially if you are a member of IEEE Consumer Technology Society, you can join. Here is a link, but you can go on the website of CTSoc and you will find this page. So last two slides devoted to the core of today's webinars, which are the technical talks. As I said, we are periodically organizing these monthly meetings with the technical committees and the speakers identified by two different technical committees to create this and foster this connection in terms of topics. This is the 17th webinar, which has been organized by the Technical Committee on Quantum and Consumer Technology, and I want to thank the officers, and by the Technical Committee on Human-Machine Interaction and User Experience. And again, I want to thank the officers for having identified the speaker. And we have two great speakers today. Professor Payman, Roj Farzad from University of Western Australia, and Dr. Federico De Laurentiis from Politecnico di Torino, Italy. They will provide two speeches on very, relevant topics of consumer technology. So I'm really eager to listen to their speeches. So I want to thank you once again for joining. I want to thank the speakers. I want to thank the officers for continuing and moderating the remaining of this webinar. And I leave the floor to them, first to QCT and then to HMI. So seeing that we have multiple speakers of the QCT, Jimbo, Edo, so the floor is yours, and thanks again.
Yeah, thank you. And on behalf of the Committee for Quantum in Consumer Technology, and Edo is the vice chair, I'm the current chair. And I would like to introduce our speaker, Professor Pageman. Professor Pageman is a distinguished medical physicist, and he's also a fellow of the Higher Education Academy. Pageman spent about 8 years developing novel medical radioisotope production techniques at a cyclotron facility, followed by his PhD study, and which led to commercialized solutions in the area of medical physics. He joined the University of Western Australia in 2013, and immediately he started to serve as the medical physics program coordinator. He published over 130 papers and being recognized with university awards for excellence in teaching, and many other awards as well. So PageMan's current research actually has extended to the promising applications of quantum computing for advanced medical image processing. Without further ado, and the floor is yours, PageMan. Thank you.
Thanks very much, everyone. Thanks, Jimbo, and thanks for inviting me. That's very exciting, and it's very interesting to be one of the speakers of the younger committee of your fantastic organization. If you don't mind, I share my slides. Can you see the slides?
Yep.
Excellent. So today my talk, as Jimbo mentioned, is quantum computing in medicine. I'm medical physicist. I'm not a computer scientist or computer engineer. And my background in physics and then nuclear medicine and radiotherapy. But we had lots of programming in our discipline, and we need to do lots of image enhancement, image processing, and treatment planning for our patients. My today's talk is I'm going to be very quick because we have limited in time, but it's going to give you a flavor of application of quantum in medicine. And probably you can see the future of medicine, which I'm thinking of definitely quantum has got a big impact. So very quick, we are in just past the fourth industrial revolution, which was AI. Now we are in the fifth industrial revolution, which is quantum artificial intelligence. Quantum computing has got lots of applications in energy materials, in agriculture science and portfolio optimizations, also in aerospace and automotive, and also signal processing and communication. Artificial intelligence is another application of quantum computing, and definitely we all know about telecommunication and learning acceleration using quantum. Cybersecurity is another area of quantum, and manufacturing and supply chain, which is a big issue for the government and big industries that quantum can help them. Finance definitely with quantum has got a huge future, and the last is medicine and healthcare. Drug discoveries, personalized medicine, protein and enzymes and vaccines, which I'm going to briefly explain what's going on. Why quantum in medicine? So quantum computing has got different applications, medical diagnosis and image processing and imaging in medicine, which quantum can revolutionize this area in different aspects that I'm going to explain briefly today. Monte Carlo simulations, definitely in radiotherapy. We have lots of issues with simulations of radiation. With cancer patients, we can use Monte Carlo directly, and because of the speed of computers we have now. So hopefully with the help of quantum, we can resolve these issues. AI in healthcare in general, about healthcare and analyzing the data, that's another area that we need to go ahead, and genomics and personalized medicine. So that's very promising parts like drug discoveries and molecular simulations as well. So because we need to go with personalized medicine, give each person his own drug, not everyone like a genetic drug. Today I'm going to explain a bit more about diagnosis. So you will see definitely lots of good opportunity for research in the future if you're interested. So especially I just want to draw your attention to CT and MRI and those type of imaging modalities. And if you're thinking of collaboration with industry, big industries in this sector, definitely promising future for research collaboration with those industries. So we know that these days we're moving to high resolution CT and MRI, but the bottleneck is larger scale type of data, and it's not really easy to cope with these numbers of information. So, but quantum algorithms, they're promising because they can, in principle, perform key linear algebra and optimization steps much faster. So this is better than this approach, definitely is better than classical processing. Drug discovery is another issue we have. So lots of drug companies are looking for better type of pharmaceutical production of the drugs. One of the issues we have with any drug, regardless of what type of drug, is that bonding affinities between the components of the molecules. If these bound or chemical bound just break, then the drug is not going to be absorbed in the target and is going to be toxic. So that's the definition between effective drug and toxic drug. So like this, you can see the component, the chemical components. Then with quantum, how can we resolve these things? We can go with and find the most effective type of energy and less energy between the bounds, and then find the most sustainable and stable type of bond between the different elements of the drug. So that's a very promising type of approach. If you're interested, you can check and find more information about these things, especially not only drug, enzymes, and vaccines. So I can say if now with the quantum computing, we were in 2019, definitely the discovery of COVID-19 vaccine was faster. So this is really a strategic plan for every government or every company to go ahead. Treatment schedules and personalized medicine is another application of quantum these days. So as we briefly discussed, personalized medicine is the future of medicine for drugs. Healthcare logistics and hospitals resources allocation for different purposes is very, very challenging for every government. So quantum can easily help us with these issues in health. And treatment schedule type of optimization in radiotherapy and chemotherapy for cancer patients. So now we have fractions and treatment schedule for patients, but every patient is similar. But definitely with discovery of genomics of the patient, we can go with more effective type of treatment schedule, not everyone the same pattern. So as just nothing extra in this text, I mentioned everything, but personalized medicine and multi-drug usage is another option that we give the combination of different drugs for different people, which is definitely personalized medicine. So one more application of quantum is compressed sensing. So it can be enhanced by quantum approximation optimization algorithms. So by using compressed sensing is a clever way to collect and reconstruct signals or images using fewer measurements. So when we say fewer measurements, for example, for MRI, which is longer process for the image acquisition, we can go with faster acquisition, and definitely will be much cheaper and more reliable because now not everyone has access to MR machines. Quantum approximation optimization algorithms, or QAOA, is a quantum computing method designed to tackle through optimization problems in situations where you are trying to find the best solution among many possible options. So now we can combine these two. Compressed sensing reduce how much data you need to capture. It means less data. For example, in CT scan, we can go with faster CT and less dose to the patient. It's less data. We don't need that huge amount of data. And by using CoreWalk, that resolve difficult math problem for reconstructions of original images. I'm going to explain CT a bit more here. We can see the 2D image of the CT scan. I'm pretty sure lots of you guys will know, but how can we, in classical domain, start to create 3D out of 2D? So the method we use in mechanic is to use this radon transform. We can see the detectors here. And when the gantry is rotating around the patient with the images, and this is the sinogram of the image, which is full of information in a KS space. So now the question is that using quantum, probably we can resolve lots of issues and discover lots of solutions in KS space. We don't need to move to X and Y and Z or Cartesian space. In KS space, we can reduce the noise, we can do better image processing, even maybe, who knows, maybe we don't need in these images with sinogram, which is full of information and data, we can detect the cancer. We don't need to just see the cancer in the image in just KS space, we can go ahead. These are all maybe the future of medicine, which is very promising. Classical reconstructions for example, for CT scan is filter back projection. And for MR is iterative solvers using those type of techniques in classical domain, which now, as I mentioned, the size of images are growing, and the computers, the current computers, they can't cope with the number of pixels and the number of resolution we go. We need a solution. We reach to the boundary, we need to cut this boundary. There is no other solution to my mind than quantum computing. So now quantum reconstructions, they use linear algebra types and use different algorithms which are listed here, but we can even use accelerated Fourier-based transform and even use quantum compressed sensing, which are explained briefly to reduce report measurements. So for example, just to give you some example, the time for acquisition, if it's 1 second, is going to be 1 to 3 milliseconds. So 300 to 1,000 times faster acquisition in images. That is very important for us, because now not all the centers they have access to quality imager, but with this way we can have better quality of diagnosis for our patient. So the other thing is hybrid quantum and classical neural network for detection of cancer or any other defects in medicine. You can see the layers. One is classical layer networking, and then we have quantum circuits. So this way we can accurately and more efficiently just do the neural network and deep learning, you can say. So a few key points here. So first of all, when we have complex pattern and we want to quickly reach to the final results, which always we're looking for these cases, then quantum definitely can help us. At least at this stage, hybrid models which are added. The other thing which probably lots of you are have heard about this is energy efficiency of quantum, because we use less electricity and is more efficient. And these days you can say more greener. If you want to grab the politicians or apply for the grant applications. So that's a really good point to mention, that is energy efficiency and more green industry. So quantum convolution neural network is another approach. You can see one of the examples for segmentation of tumor segmentations. We can accurately do these things, but classical convolution neural network, they can do the same, but this is much faster. And sometimes for complex situations, it's very fast. So the other very brief application is denoising using quantum many-body physics. So we use Hamiltonian, which is Schrödinger equation, to find the energy map for it. Yeah, you can see here, that's a potential map. And then the method is to split images into patches, and you can see these patches here. And briefly, I just want to mention not so much information, but yes, inter-patches interactions need to be defined and build adaptive content bases based on Schrodinger equations and then compass. The key results, then, for example, for this specific paper they mentioned, this is works for both Gaussian and Poisson noises. So Poisson noises and Gaussian noises can be removed, which I'm going to show you some example here. As you can see, if we have input noisy image, then the output as a one of the quantum interaction is like that. And we can see the profile, the red line is the quantum many patch interaction. So you can see we preserve the edges unless fading the edges. Or maybe this is a bit better explanation. You can see the ground truth image, noisy image, and we use different algorithms here. But the last one, which is denoising by quantum iterative patches, you can see we preserve the edges, no blurring, and also very detailed parts has been preserved. We can't believe this is the same image. I mean, the original was this one, and we reached to this one. So that would be revolutionized, really, medical images, especially when we're dealing with ultrasound images, because ultrasound is full of noise. So the last slide, which I reached to the 15 minutes of my talk, is amplitude estimate, which we use in Monte Carlo modeling. So we use Monte Carlo modeling for treatment planning in radiotherapy. So half of the patient with cancer, they need radiotherapy. So definitely Monte Carlo can help us. But as I said before, CAD Monte Carlo models are very extensive in terms of time. So we can use it in clinic. We don't have resources, we use mathematical models, but we check the mathematical models with Monte Carlo to verify the system is working well. But for routinely for patients, we use mathematical models. Definitely quantum can help us to do real quantum for patients, which would be great. The other application is epidemiology using quantum, again, Monte Carlo simulations and clinical trials to estimate the patient outcome. We have good estimation based on Monte Carlo simulations, and also risk analysis estimation of probabilities of treatment success. So, and side effects, we can easily predict our treatment success for each patient and also predict the side effects. So thanks very much. Hope to see you sometime in Australia.
Yeah, thank you, Pejman. Okay, yes, yeah. So maybe I don't think we have time for questions, but if anyone want to ask something, please leave your question in the chat, and Pejman will respond. Just due to the time constraint, maybe we will move to the next speaker. Thanks again, Pejman.
Pleasure.
Okay, I can take the field and I will present the speaker for the Human Machine Interaction and User Experience Technical Committee, which is Dr. Federico De Laurentiis, which is currently a research fellow at the Department of Control Computer Engineering of the Politecnico di Torino, a member of the Graphics and Intelligent System Group and of the VR at Polito Lab. He received his bachelor, master, and PhD degrees in computer engineering from the Politecnico in Italy in 2016, 19, and 24, respectively. And his research activities focus on the use of virtual reality and augmented reality for the training of users in both formal and non-formal contexts, and also covers virtual heritage, human-machine interaction, and social interaction in virtual environments. You can start, Federico.
Thank you, Davide, and thank you all for the opportunity. I will now share my screen. Well, okay. Tell me if you see.
Yes.
Okay. Well, hello everyone. As said, I am Federico De Laurentiis, and I am a member of the Technical Committee on Human and Machine Interaction and User Experience. And today I'm here to talk about immersive education, in particular with a focus on the role of VR in both non-formal learning context and structured curricula. Let's start with a brief introduction. As said by Davide, I'm currently a postdoc assistant researcher at the Department of Control and Computer Engineering of Politecnico di Torino, and I'm working with the Graphics and Intelligent Systems Research Group. And I mainly focus on extended reality, but my interests are various, such as education, cultural heritage, in particular virtual heritage, human-machine interaction, and social interactions, among the others. Here you can find my contacts. Now, in recent years, the necessity of improving the delivery of educational content has led to an increased interest in technological solutions able to revolutionize traditional teaching approaches, and many efforts have focused in particular on integration of virtual reality into training scenarios due to its intrinsic advantages. In particular, it's well known that VR can produce relatively affordable training systems, and in this presentation, this will be abbreviated as VRTSs that are easy to deploy and enable the fruition of high-fidelity realistic simulations and can be integrated into training experiences to enhance their effectiveness. And also they allow the use of automatic evaluation and scaffolding systems and multi-user functionalities. Based on all these considerations, so VR is particularly useful for the acquisition of procedural and practical skills, and has been proved to be more effective than traditional teaching material in this context. However, despite these advantages, there are still various challenges that you can see in this slide pertaining the use of VR in education that remain currently unresolved or currently under investigation. And someone is writing on my slide, I don't know. And namely, these challenges are that the effectiveness of VR in this context is still up to debate in terms of performance and quality of the final experiences. And also, among the many instances of VR-based training experiences, the majority leverage applications that are context-dependent, and the creation of new system often revolves around custom-made solutions that are often limited to a specific case study and seldom usable. And also, since VRTSs are very different from each other with limited common elements, these systems are often used as standalone tools and without a specific rationale with respect to on how to integrate them in training experiences and especially existing courses. Now, these challenges are further exacerbated by the heterogeneity of the educational context, and in particular by the division between non-formal education, where VR is usually accepted, and structured curricula, where the use of VR is still scarce and under-investigated. The situation is mainly due to the intrinsic differences between the two contexts. In particular, in non-formal learning settings, for instance, training in companies, training is focused on a specific task, is targeted towards a small group of trainees, and delivery of the educational context is non-structured, and in some cases, it's based on, let's say, some generic solution with no precise assessment of individual learning outcomes. While on the other hand, in formal learning settings, typical of schools and university, for example, it is required to improve existing structured learning experiences, where the introduction of new learning tools can be critical and can cause some problems. Education, moreover, is targeted towards large classes and often is necessary to deal with a limited number of different and low-end devices. Now, where to start? To, let's say, accompany you in a possible pipeline to integrate VR in formal and structured courses, we have to start in non-formal education, where VR currently thrive. In particular, we start from two of my studies that are representative of, in general, of these kind of solutions. Specifically, the first study revolved around the training operators of Italian Air Force in a decontamination procedure, whereas the second one targets the operator from Italian Civil Protection and train them on the procedural aspect of hydrological response. Sorry. These two studies are just example, but both adopt a pretty standard structure, namely they're both based on multi-user and multi-role and customizable platforms, and are characterized by automatic guiding system and evaluation modules, and both were tested with the domain expert and evaluated using both subjective and objective measures through standard questionnaires and custom quizzes developed with the help of expert trainers. What we can derive from this study is that the contribution of domain expert is crucial, in particular of expert trainers, in order to create good and sound and targeted training experiences. Moreover, the methodology adopted in these two studies to assess the quality and effectiveness of the systems proved to be useful and is thus reusable in following studies. And moreover, however, we have the need to confront such system with existing traditional approaches to clearly understand if they represent a viable and usable training solution that can be a complement or a substitution to existing approaches. Starting from this consideration, we can pivot towards the more structured curricula, although I will present you now a study that is still, let's say, rooted in non-formal education. Namely, I will now show you, if my PC decide to, okay. Another study that targeted first responders and specifically firefighters from Antincendio Boschivo from Piedmont region. Usually the considered trainees of this course attend a standard structured video-based course that focuses on the acquisition of practical skills. Trainees cannot be exposed to real fire, and the use of VR so could overcome these limitations. So we wondered if it was possible to use VRTS to introduce a realistic learning by doing component in this existing course. Working together with expert trainers, the VRTS was designed as a training instrument that focused on the use of manual firefighting tools such as the shovel, the rake, and the beater, which were simulated through the use of a tracker-based passive haptics interface that you can see in these pictures. The system also provides a plausible reactive cell-based fire spreading that you can see in the video, and that was used to replicate the condition of real firefighting operation. Moreover, based on the result of the previous study, a detailed light and voice-based guiding system together with an in-depth evaluation module were added to the application. Due to the intended aim of comparing the device VRTS against the traditional learning solution, as well as in order to organize a fair comparison to correctly isolate the contribution of virtual reality, a low-fidelity marker-based real practical experience was also devised, which is the one in the top row. So a three-way comparison was organized, contrasting the traditional video-based course based only on video lesson, targeting the use of the shovel, the rake, and the beater, and was compared with two training experiences, one using the low-fidelity real solution and the other using the VRTS that was devised. Based on the previous studies, subjective measures were once again collected using standard questionnaires, and objective measures were collected through real-life low-fidelity exam attended by all participants and followed by expert trainers. Subjective results showed an overall preference toward the practice-based solution. However, the most interesting thing is that the most interesting results were achieved in terms of objective evaluation. Despite the additional practice time, in fact, no difference were found between the traditional course and the low-fidelity experience, whereas the VR-based approach outperformed the others in the operative part of the exam, that is, in the actual use of the considered firefighting tool, in terms of the overall score also. This confirmed that the VR could be used effectively to introduce a learning by doing component, overcoming the limitation of a traditional course and the limitation of low fidelity, non-automatic real exercises. This study does represent an example of how to integrate VR into an existing course, although still rooted in non-formal education due to its focus on practical skills. Specifically, it showed that by using the considerations and guidelines developed in the formal studies, conducted in non-formal education, it was possible to use VR successfully and effectively also in structured courses. Moreover, besides confirming the previous consideration, this study was useful to understand how to perform a fair comparison between VR-based and traditional approaches and why it was necessary, so to isolate VR, the contribution of VR specifically. At this point, we have all the foundation necessary to finally use VR in a structured course, namely a university course on measuring procedures and electrical switchboard that was, let's say, performed here in Politecnico. However, there are still several questions. Specifically, we have to understand if VR-based approach can be effective in this context, and then how to integrate these approaches into existing curricula, and finally, how to use these approaches to better leverage their potential. To answer this question, I will now present you a final study that focuses on the laboratory activity of the aforementioned course. And although its objective is the development of procedural skills, and therefore practice should be critical, due to safety reasons, in the current course, the activity is usually limited to a passive demonstration carried by the professor. Based on the previous result, the introduction of VR should then be able to overcome this limitation, and therefore the study focused on two research questions. The first one aimed to determine how to integrate VRTS into an existing learning path, whereas the second one aimed at building upon the first answer to further investigate whether it could be possible to use VR with a pedagogical approach typically not considered in immersive experiences, that is, learning by teaching. According to the guidelines developed in the previous studies, the device VRTS was designed with the contribution of domain experts and trainers, both from industry and university, and aimed at simulating all the steps of the considered procedure, providing also multiple alternative paths and multiple usable instruments to fail to fully reproduce the real procedure. Once again, the VRTS presented two training modes that were already used in the previous study: a detailed step-by-step guiding mode that used highlight and multi-language voiceover, and evaluation module leveraging both diegetic feedback and a final evaluation report that can be used by the trainers. To answer the first question, understand how to integrate VRTS into an existing learning path, a first experiment was conducted comparing three alternative learning approaches. One using the experience, once experiencing only the traditional laboratory activity, a second group experiencing the traditional activity followed by the VRTS, and a third one experiencing only the VRTS. This configuration aimed at understanding the effectiveness of the device system together with its effectiveness as either a complementary tool or as a replacement tool. Results show that although both VR-based experiences outperform the traditional activity in the quiz, when evaluating the capability of remembering the general structure of the procedure, only the student who experienced the VRTS alone performed better than the traditional laboratory activity when tested on the acquisition of the finer operational details. Showing that the VRTS was able to overcome the limitation of traditional activity, but also that the laboratory activity introduced a bias, undermining the effect of the VRTS in the combined approach. Finally, the second research question was addressed by running a second study that built on the previous one and contrasted a traditional use of VRTS as a replacement to the laboratory activity, in which students were asked to experience the guided mode followed by the evaluation module to learn the procedure, against the use of VRTS in a learning by teaching scenario, where students experienced the guided mode and then guided other students inside the evaluation module. This approach proved to be useful in traditional educational scenarios, but its use in combination with VR was still under investigated. Results show that for what concerns the operational details of the procedure, it was possible to notice that the gain associated with the learning by teaching approach was significantly greater than the other, and this trend was also true for the retention of the operational details, confirming what was observed in the literature in other learning by teaching based contexts. So the study built upon all the consideration and guidelines developed in the previous one and showed that it is possible to successfully use VR experiences in formal education, even as a replacement of traditional approaches. Moreover, it showed that the use of VRTS instances in combination with uncommon pedagogical approaches can further enhance the advantages associated with this technology. However, it is worth noticing that in the combined use of VR, the RBT approach was possible only thanks to the presence of a detailed automatic guiding system and an automatic evaluation module. So these aspects are, let's say, imperative for VRTSs. Now, to conclude, to understand what's next in this pipeline, we can see that the use of VR in structured curricula is not limited, instead opens a variety of possibilities, therefore leveraging the multitude of existing and low-end devices, or trying to accommodate larger classes using pedagogical approaches that are uncommon for virtual reality. And in the future, the next steps for this technology focus on streamlining the creation of VRTSs, namely on the procedural generation of VR scenarios versus the currently hard-coded nature of VRTSs, and the use of adaptive learning and tailor-made solution using machine learning to improve the quality of existing VRTSs, and the potential use of generative AI either for authoring of VR experiences or as a tool to tackle existing VR experiences. And with this, I conclude my talk, and I thank you all for the attention.
Thank you, Federico. And I think that there may be room for at least one quick question from the audience. So if some of you have a question, because we cannot do that then with the chat, because then there is not another speaker. So if no one has a question, I have a quick question related to the application to formal contexts.
Yeah.
Are there differences with respect to the level of the courses, like universities or high school? Do you think that there is more room or more, let's say, advantages targeting one kind of one of the levels, and then maybe it will propagate after the adoption of the tools?
Well, the main difference that I can see is that when we tackle formal context with, let's say, the target younger students, we have more room to use more gamified solutions. Basically, we can, let's say, introduce element typical of video games, such as time travel or gamified feedback, or at least even also a simple overall score that can be updated during the experience. And these elements proved to be effective also in studies that were conducted. And however, these elements can be a little bit more, let's say, difficult to integrate in higher education due to the fact that maybe are less accepted by the students and the teacher also. However, these elements can be, I think, translated and transported even in higher education. The point is just how to present them in a way that does not diminish the quality, the perceived quality of the overall application.
Okay, thank you. There is also a question from Vivek.
Yeah.
Yes. Thank you for the very nice talk. I wanted, so let's say that you are training someone from safety background for a very specific safety application, and how much, and typically when we do these kinds of steps in the lab, we would have something like maybe show a shovel, and just the shovel is moving, maybe the hands are not shown per se. So how much of that would you say is important, especially in mimicking the actual activity, and how much of transfer of training is getting affected? So let's say an example is that, I am from the point of view of a worker, I am trying to show that the worker should shovel in a particular angle. Or maybe, so just for the ease of it, I am not able to show the full hands and other things because my computational power may be affected, or I'm not good at all of those things. So I just show a shovel and then I transfer, showing that this is the angle. So in these cases, how much of transfer of training really happens, or what are your thoughts about transfer of training, given your examples you showed?
I have to start with a premise, that is that in the study that I showed you, we also tracked the hands of the person together with the head of the person, and through an algorithm that ran in the background of the application, we extrapolated the approximate position of the body and to perform calculations, since in that particular case, the position of the body was, let's say, crucial for the actual evaluation. So depending on the context, the position of the body, at least an approximate position, is crucial. And in that case, if we didn't have the tracking of the hands and the head and just of the shovel, it would have been impractical to use that application, because it was imperative to understand the relative position of the person with respect to the simulated fire. So depending on the application, at least a certain amount of tracking and approximation of the body is necessary. And I agree with you. If that's not possible, I mean, at least through the position of the head-mounted display, which we should have in a virtual reality application, we can approximate where the user is actually standing, but it's not, let's say, ideal, because it would be maybe also detrimental, because it could be lead to some biases. So it is necessary, depending on the task, to have some kind of tracking, to have also an effective training component.
Okay, thank you.
There is a question from the audience in the chat. I will read it from Byron Alfonso Perez Gutierrez.
Okay.
How do you recommend starting the development of VR-based courses for teachers that are not VR developers?
Okay. The answer is twofold. If the teacher have a contact with such, I don't know, a researcher such as ourselves, the best thing to do in that case is to is to use the teachers as a resource and use their feedback to pilot what we developed. So if we can interface with the teacher and we can actually develop the application, we just have to use them. Use is the wrong term, but we have to leverage them as a source of information. If instead you're talking about a single teacher that want to develop an application that can be used in his or her course, the ideal thing is maybe not using a game engine, which can be problematic, can be cumbersome, can be heavy to learn, even though nowadays you can use no-code approaches. But I say that you can use existing metaverse applications such as Horizon from Meta and even VR chat that can be used, or Roblox that can be used with a simple version of a code editor and a simple version of a game engine, and can be employed to develop a simple training solution. We actually have a study currently under development, let's say, where we are trying to test how these platforms can be used even by non-expert to create simple training applications. So my suggestion is to move towards that kind of scenarios and that kind of solution, because they are created and designed to accommodate, let's say, non-tech savvy users. I don't know if I answered the question or if you have any other doubts.
Thank you. I think a last one, I suppose quick. Thank you for your presentation, says Zambujal Oliveira. Are you thinking about studying any application related with circular economy or supply chain and reverse logistics, like fields of applications?
It's certainly in a very good direction, although it's still the main point, the focal point is to understand if virtual reality is maybe the best solution for this kind of approaches, namely because when you use virtual reality, you should focus on the, let's say, hands-on and practical skills of the user, while for some more high-level and high-level solution, high-level procedures, maybe it's not as necessary to add, let's say, the cognitive load associated with the head-mounted display, and maybe a virtual reality solution is not the more appropriate way to follow. Although it can be interesting, and we have done some studies in understanding if virtual reality can be used also in a non-practical, non-hands-on application with good results. So it's certainly a way that I want to explore, and I will in the future.
Okay, thank you, Federico, again. I think that can leave the field to Fabrizio.
Yeah, I think that we had great presentations today, also great questions, and of course this is based on great speakers and great attendees. So thank you again to our speakers. Thanks for all those who attended. Thanks for the officers of the TCs that coordinated, moderated this talk, and well, I hope that you will join us again next month. We'll have the next webinar, and the same date will be announced soon. So thanks again. Bye-bye.
Thanks.
Thank you, everyone.
Thank you.
Bye-bye.
Goodbye, all.
Thank you. Bye-bye.
Bye-bye.